2-1 solving equations. When we're solving equations, we have an equation, which means there's an equal sign in it, with a variable or a letter within those equations that we want to get by itself. If we look at example 1a, we have x minus 8 is equal to 17. So we want to get x by itself. So we're going to move that 8 over. So we're going to use inverse operations. So instead of subtracting it, we're going to add it to both sides. And we get that x is equal to, and we're going to add the 17 to the 8. The 7 plus 8 is 15. And then 1 plus 1 is 2, so x is equal to 25. If we look at b, we have x minus 3 is equal to 5. So again, we want to get x by itself. We're going to add 3 to both sides and get that x is equal to 8. Whatever you're not working with, you want to remember to bring it down. Sometimes you're going to be working with these equations, and they're going to be more than one step. The ones that we just did, A and B, are one-step equations. So again, sometimes you're going to be working with some of these equations that are more than one step. So you want to make sure that you bring anything down that you don't work with at that time during that step. If we look at C, we have x minus 7 is equal to 13. So we're going to bring that 7 to the other side by doing inverse operations. Right now there's a subtraction in front of it, or minus. So we're going to add 7 to both sides. When we do this, this x is going to be dropped down, and x is going to equal 20. Remember, with any equation that you are solving, you can always substitute in your answer or plug in your answer to the original equation and see if you get a true statement. If you do, you know your answer is correct. If we look at example 2, we are going to be solving for n in example 2a. So if negative 5 is equal to n plus 13. Again, we want to get that n by itself. So the term that's on the same side as that n is the 13. So we're going to subtract 13 from both sides. Remember, when we are subtracting, if we have two signs that are the same, we're going to keep the sign and add the numbers. So n is equal to negative 5 plus negative 13, which is negative 18. Again, we said that n was equal to negative 18. If we look at b, we have x plus 5 is equal to 9. So in order to get that 5 over to the other side of that equal sign, we're going to do the opposite of addition and subtract 5 from both sides. So we get that x is equal to 4 because 9 minus 5 is 4. For c, we have x plus 15 is equal to 27. So to get x by itself, we're going to move that 15 over by subtracting it from both sides. So we have that x is equal to 7 minus 5 is 2, and 2 minus 1 is 1. So x is equal to 12. If we look at our next set of examples, we're solving, S-O-L, solving, should be an L there, the equation by using multiplication property of equality. So when we're looking at example 3a, we have m divided by 3 is equal to negative 5. Remember, fractions and division are the same thing. So in order to get that m by itself, we're going to multiply each side by 3. And negative 5 times 3 is negative 15. So m is equal to negative 15. Again, we're doing the opposite operation that's happening here. If we look at b, we have 8 is equal to negative 2/3 times x. So the opposite of multiplying by that 2/3 is going to be dividing by it. Remember, when you're dividing fractions, you're also multiplying by the reciprocal. So the reciprocal of this negative 2/3 is going to be a negative 3 over 2. And we're going to multiply the 8 by negative 3 over 2 as well. So those cancel out. We're left with x is equal to, the 2 is going to become a 1, and the 8 is going to become a 4. So negative 3 times 4 is negative 12. Remember, you can simplify before you multiply with these fractions. If we look at c, we have negative 7 is equal to negative 7 over 2 times x. So again, we're going to multiply by the reciprocal of that negative 7 over 2, which is negative 2 over 7. So that 7 on the other side is also going to be multiplied by the negative 2 over 7. These cancel out on the right side, leaving us just with x. And then we have 7 as our denominator and 7 as our numerator. So they're both going to become 1s. And a negative times a negative is a positive. So 2 times 1 is 2. If we look at example 4, we're now working with multiplication with whole numbers. So we have something like 6 times x is equal to 222. Well, the opposite of multiplication is division, so we're going to divide each side by 6. And we get that x is equal to, well, 6 goes into 2 0 times. So we got to look at the 22. 6 goes into 22 3 times with 18. We'd have 4 left over. So 6 goes into 42 7 times. So x is equal to 37. For b, we have 8x is equal to 16. So in order to get x by itself, we're going to divide each side by the coefficient of x, which is that 8. And 16 divided by 8 is 2. So x is equal to 2. For c, we have negative 25x is equal to negative 75. So to get x by itself, we're going to divide each side by negative 25. Remember, a negative divided by a negative is going to give us a positive, and 25 goes into 75 3 times. So x is equal to 3. Like I mentioned earlier, sometimes you're going to be using more than one step in order to solve these equations. If we look at example 5, we are solving these equations by using multiple steps here. So if we look at A, we have 3x minus 2 is equal to 6. Whenever you're working with problems like this where there's more than one step that it includes in order to solve, you want to undo addition or subtraction before you undo multiplication or division. So with A, we have 3x minus 2 is equal to 6. We would add the 2 to both sides first to get 3x is equal to 8. And then we would divide each side by 3 to get x by itself. And we get that x is equal to 8/3. If you wanted to turn it into a mixed number as well, you can give me that x is equal to 2 2/3. For b, we have 1/2 x plus 4 is equal to 10. So again, we're going to undo that addition first before we undo the multiplication of that 1/2. So we're going to subtract 4 from both sides. And we're going to be left with 1/2 x is equal to 6. From here, multiply each side by the coefficient of, the reciprocal of that 1/2. Well, the reciprocal of 1/2 is 2. So we'd multiply each side by 2 to get x by itself. And 6 times 2 is 12. If we look at C, we have 5x minus 10 is equal to 20. We're going to get the 5x by itself first. And we're going to add 10 to both sides. We're left with 5x is equal to 30. Again, we didn't use that 5x. That's why we're dropping it down. From there, get the x by itself. Divide each side by 5 since it's being multiplied by 5 now. And you want to do the opposite of multiplication. So x is equal to 6. For D, we have 1/3 x plus 9 is equal to 21. So we're going to move that 9 over first to undo the addition. And we're going to be left with 1/3 x is equal to 21 minus 9 gives us 12. From here, you want to get the x by itself. So we're going to multiply each side by the reciprocal of that 1/3. The reciprocal of 1/3 is 3. So 12 times 3 gives us that x is equal to 36. If we look at example E, we're given 5n minus 9 is equal to 71. So first we're going to move that 9 over by adding it to both sides. And we get that 5n, we're dropping that down, is equal to 80. From here, we're going to divide each side by 5 to get n by itself. And n is going to equal, 5 goes into 8 one time with 3 left over. So 5 goes into 30 6 times. N is equal to 16. For F, we have 1/2 x plus 3 is equal to 9. So we're going to first move that 3 over by subtracting it from both sides. And we get 1/2 x is equal to 6. From here, multiply each side by the reciprocal of that 1/2, which is 2. So these 2's, the 2 and the 1/2 would cancel out to leave us with x. And 6 times 2 is 12. So x is 12. If we look at some extra examples, for example 1, we have 2x minus 1 is equal to 11. We're going to add the 1 to both sides and get 2x is equal to 12. From here, divide each side by 2, and we get that x is equal to 6. For example 2, we have 4n plus 9 is equal to negative 3. Subtract the 9 from both sides. Negative 3 minus 9 is negative 12. Bring down that 4n. So 4n is equal to negative 12. Divide each side by 4 now. We get that n is equal to negative 3. If we look at 3, we have negative 2x plus 5 is equal to 19. We're going to subtract 5 from both sides. And we get negative 2x is equal to 14. From here, we're going to divide each side by negative 2. And we're left with x is equal to negative 7. For 4, we have 1/2 x plus 7 is equal to 6. We're going to subtract 7 from both sides and be left with 1/2 x is equal to negative 1. From here, the reciprocal of that 1/2 is 2. So if we multiply each side by 2, we're going to get that x is equal to negative 2. For 5, we have 2x over 3 is equal to 8. I'm just going to rewrite this so that way it's a little bit easier to work with. I'm not writing over things. So that 2x divided by 3 is equal to 8. The opposite of the division is multiplication, so we're going to multiply each side by 3 to get 2x is equal to 24. From here, we're going to divide by 2, and we get that x is equal to 12. We could have also multiplied each side by 3 over 2, which is the reciprocal of that 2 over 3. Remember, 2x over 3 is the same thing as 2/3 times x. So again, we could have also multiplied each side by the reciprocal of 2/3, which is 3 over 2. For 6, we have x plus 5 over 3 is equal to 7. So again, I'm going to just rewrite this so it's easier to see everything happening. So from here, I'm going to get rid of that 3 on the bottom of my denominator. Instead of it being there, I'm going to multiply each side by 3, which will actually cancel out the 3 and both the denominator and the whole number to leave us with x plus 5 is equal to 21. From here, we're going to subtract 5 from both sides, and we get that x is equal to 16. For our last example, we have y minus 5 all over 4 is equal to 8. So I'm going to multiply each side by that denominator to get rid of the fraction. So the 4's would cancel out, leaving me with y minus 5 is equal to 32. From here, I'm going to move that 5 over by adding it to both sides, and I get y is equal to 37.